Okay, so welcome back. On today, we're going to be talking about forces, and I'm not going to bore you too much with what a force is because I feel like most of us probably know what a force is. But I do just briefly want to go over it for anyone who doesn't quite understand. So you're just following along with your worksheet. It says when you ride a bike, your foot pushes against the pedal. The push makes the wheels of the bike move. So the word pushes is bolded because pushes is one type of force. So anytime you push something, that's a force. When you drop something, it is pulled to the ground by gravity. So a pull is also a force. So a push or a pull is a force. So a good definition for force is a push or pull in a particular direction. Forces affect how objects move. They may cause motion. They may also slow, stop, or change the direction of motion of an object that is already moving. So I want you to take a second and pause this video and answer the question on the right-hand side. It says, give an example of a pushing force and a pulling force at school. So for example, not at school, one pushing force is riding a bicycle. One pulling force is when you drop something. It pulled to the ground by gravity. So take a second, pause this video, and tell me two examples, one of a push and one of a pull at school. So I'm going to give you a quick example for pushing. When you go to the bathroom stalls, you have to push the doors open. A pulling force is, let's say my classroom door shuts before you're inside. You would have to use the lever or the knob to open it, and that requires you to pull it open. So those are two examples. Make sure that you have this box filled out before going on in the video. So it says forces affect how objects move. They may cause motion. We just read that part, so I'm not going to reread it. Sorry. Forces can affect motion in several ways. So it can make things start moving faster, moving slower, just start moving in general. It can make it stop moving, change direction, or change shape. So looking at the bottom of your sheet, it is showing you two cubes, a blue cube and a white cube. And it's showing all these different forces acting on the cube. So you can see one's coming down, one's coming up, one's coming left, one's coming right. When all of those forces are acting on the object at once, we only see the object do one thing, and that is a result of whichever force is heaviest. So for example, up and down. Going down, we have 5 newtons, so that capital N stands for the word Newton. That's what force is measured in. So for example, when we measure our desk, we might say it's about 13 inches. Inches is a unit. In this case, force is measured in newtons. So it's going 5 newtons down and 5 newtons up. So it's not going to move up or down because those two forces are equal. They both equal 5, so it's not going to move it up or down. Neither one is stronger. However, when you look at the left and the right, you can see on the right it's pushing actually this way to the left, 10 newtons, and this is going to the right, 5 newtons. So we look at which one's greater. Obviously 10 is greater than 5, so that means that this cube is going to move this way, because that's the direction of this force. So it's going to move with that force. So down below, where it says direction, we can say the direction is going to move this way. And the force is whatever the difference is. Difference means subtraction. So if this is saying 5 newtons, this is 10 newtons. 10 minus 5 is 5. So we have 5 newtons of force. Now let's say, just for example, if this force wasn't there and we still had 10 newtons of force, well, that means more force is going on the cube and we would have 10 newtons of force. But this 5 newtons cancels out 5 of these newtons, which only leaves me with 5 newtons of force. Go ahead and pause this video, see if you can figure out the direction and the force of number 2. You can come back to check your answer when you're done. So on this one, starting with left and right, they both say 5 newtons, so it's not going to move to the left or the right. But the difference comes with the up and down arrows. So this is coming down 5 newtons. This is going up 10 newtons. So this is the greatest force. So for the direction, it is going to move the cube upward. And again, we're subtracting. So 10 minus 5 is 5. So it's going to receive 5 newtons of force. Make sure that you recorded your N as well. Going along to the next part of the page, it says examine the forces acting on the freezer in the diagram and answer questions 1 through 3. So you can see, same kind of thing. This is not a cube, now it's a fridge, but we still have arrows of force in different directions. So, number 1, are there any of the forces acting on the freezer that are balanced? If so, which ones? So this one doesn't really tell you in newtons necessarily what's going on, but you can look at the size of the arrows and see which ones are balanced, because balance just means equal. So if you look with the up and down arrows, they are about the same length. So that's showing you that the fridge is not going to move up nor down. But if you look at the where it says F's, one's a push, one's a pull, you can see that this push arrow is a lot longer than this arrow. So these are not balanced. So going back to our question, which ones are balanced? We're going to say the W and the N. And I guess this would technically be a yes, and this could be moved down here. Sorry about that. On number 2, are any of the forces acting on the freezer unbalanced? If so, which ones? So yes, we just talked about these 2. So yes, and the 2 are the push, and the other one's called friction, which is just, in this case, the pull. And then it finally says describe the motion of the freezer. So again, remember that if forces are balanced, they cancel each other out. So in this case, the up and down are canceling each other out. If this is being pulled this way and this is being pushed, whichever one is stronger is the one that's going to result. So it's going to be pushed. So it's going to the left. On number 4, it says 2 men of equal strength have a tug of war. Draw the forces that are acting onto the picture. So on number 4, which man will win the tug of war, left or right? Well, it says, going back, it says they have equal strength. So left or right, we can't really say because they both have an equal force. So on this one, we're just going to circle and we're going to put equal force. We don't know who would win that one. On number 5, another man joins each end of the rope. Does this affect the result of the tug of war? If not, why not? So if another guy is added here, another guy is added here, the forces are still equal. Okay? Just because we added something didn't change anything because we added it to both sides. So does this affect the end result of tug of war? No, because the forces are still balanced. Moving on to the next one, another man joins the team on the left. Which team will win tug of war now and why? So now we can say that this side has more people, so it has more force. So the left side will win because it has more force. It has more force. Moving on. It says in the picture for question 6, each man pulls with a force of 10 newtons. How much force should the team on the left pull with? So if this is 10 and this is 10 and this is 10, then we have 30 newtons. And then on the right, if this is 10 and this is 10, then we have 20 newtons. And then finally, explain the result of tug of war using the values from the forces in each team. So we said that this team would win, and the reason that they would win is they are pulling with an extra 10 amount of force. So 30 newtons minus 20 newtons is 10 newtons. So I'm actually going to write that here to show what's going on. Okay. On the back side of your sheet, the number one thing that we're going to be learning over the next week for next Wednesday's quiz is how to use science formulas. So this week is going to be learning how to use formulas for force, speed, acceleration, velocity, and work. So on today, we're just going to focus on the force equation or formula and the way that we solve force when we don't know all of the values is we use force equals mass times acceleration. So I want to talk just real quick. Over here, we're subtracting because we know everything's in Newton, where force is already found for us. Here, we're actually finding the force. So these are kind of two different things. So this is going to be our equation. It says be sure to always write the equation. So yes, you have to show your work just like you would in math class. Plug in the numbers and the units. So remember, force is measured in newtons. And give the answer with the correct number of newtons. So I'm going to do a couple with you, and then I'm going to let you try some on your own. Okay, two quick things I jotted up here for you. Since the force equation uses the words mass and acceleration, we talked about what force is, but I just briefly want to talk about what mass and acceleration are. So mass is the size of something, and acceleration is movement. So you might want to jot that down because on these questions, it's not going to say the mass is 2. The acceleration is 2. You're going to have to read the question and figure out, is it talking about mass? Is it talking about acceleration? Which one is which? So, again, knowing those definitions will help you. So, on number 1, a man hits a golf ball of 0.2 kilograms. This is our mass because it's the size of something, which accelerates, hint, hint, acceleration, at a rate of 20 meters per second squared. So this is our acceleration. What amount of force acted on the ball? So if force equals mass times acceleration, that means I can take these two numbers, multiply them, and that will give me the force. So hopefully in your math class you have learned to write these up and down from each other. And remember, you don't have to line up decimals if it's multiplication. We're going to pretend like the decimal's not there and multiply. So 2 times 0 is 0. 2 times 2 is 4. And however many numbers are after the decimal in the problem, that's how many numbers should be after the decimal in the answer. So looking here, how many numbers are after the decimal? 1. So I want to put a decimal here, so there's only one number after the decimal. So go here. So the correct answer then would be 4, and ignore my pen, sorry, would be 4 newtons. Because remember, force is measured in newtons. Okay? Go ahead and read number 2, see if you can figure out which one's the mass and acceleration, and go ahead and try it. So this one was easy to figure out, mass and acceleration, because it used the word mass and accelerates. So you should have just multiplied 18 times 3, and you should have gotten 54. Make sure that you labeled it newtons, since force is always measured in newtons. On number 3, go ahead and pause. Go ahead and try number 3. So on this one, we had 25 times 5, and you should have gotten 125. And then make sure again that you labeled it newtons. Go ahead and try number 4. Okay, so on this one, the mass was 50, the acceleration was 4. 50 times 4 is 200, so the correct answer is 200 newtons of force. Please make sure at this point that you are writing the math equations and showing your work. You will not receive credit for your notes when I do a binder check if you have not shown your work. Okay, flipping, go ahead and try 5, 6, and 7. Come back after you have finished all 3. Okay, so first, forgive me, on number 7, you can skip it. You probably tried to do it, and you probably thought you did it right, but on this one, with the acceleration, they didn't really give you an acceleration, they give you a speed, so you had to change it. Notice that this one said 10 meters per second instead of meters per second squared, so this you would have to change before you could solve it. So again, I'm not going to get into all that, so just ignore it for right now. I do also want to talk about real quick on number 6. Make sure that you put the longer number first. 9.8 should be first. Check your answers, check your units. Let me know if you